Hi, it's Mark here. Welcome to our presentation on S-Planning, building pedagogical content knowledge and planning for the children in your class. There are two videos. One explains the what and the why, and the second video will explain the how. Pedagogical content knowledge is understanding both the content that we're going to teach, for instance, how to add fractions, the usual ways in which children learn the concepts, so for instance the small steps that make up a larger idea, and the common misconceptions, for instance adding both the numerator and the denominator. How important is it that teachers have good pedagogical content knowledge? There's quite a lot of good evidence to suggest that pedagogical content knowledge is really important. The Williams report in 2008 suggested that the pedagogical content knowledge of most primary teachers was not up to date or adequate, and suggested training at least one maths specialist teacher in each school who would cascade this knowledge to all teachers. The MAST programme, which followed, trained lots and lots of teachers, but unfortunately they weren't able to influence the teaching and the general direction of maths in most schools. The EEF guidance reports, Key Stage 2 and 3, and the Early Years Key Stage 1 both highlight the importance of teachers' pedagogical content knowledge. And the report What Makes Great Teaching by Coe et al. In 2014 was a meta-study of the aspects of teaching which most contribute to good teaching, found strong evidence for pedagogical content knowledge as one of the two most important aspects of making great teaching. This relatively low level of teachers' pedagogical subject knowledge is emphatically not the fault of teachers. Some contributing factors may be research, for instance, by the Teacher Development Trust has suggested that traditional forms of one-off CPD are far less effective than longer-term collaborative CPD, so the odd staff meeting on a maths topic not particularly effective. The 10 months of initial teacher training do not really enable early career teachers to develop really more than a simple understanding of the pedagogy and didactics of maths. Official sponsorship of approaches which take the emphasis away from teacher knowledge in favour of a manual for teaching maths and schemes, which are sometimes little more than some pages of well thought out questions with no pedagogical guidance. There were some good aspects of the national strategies, but they deprofessionalised many teachers into following schemes rather than developing a good understanding of the pedagogy. The Williams report and many other studies have shown that in the UK we have a societal problem of negativity towards maths, and school teachers and school leaders are not exempt from this, and it might colour many CPD choices. A mastery approach to teaching maths has become popular in recent years, largely due to the government's promotion of teaching methods which are popular in South Asian countries. But what is mastery? It's important that we have a shared understanding of what we mean by it. A long-standing concept of mastery is that it involves teaching concepts to the teaching group until the vast majority of them have understood it to a reasonable depth, as we've discussed many times. The NCETM, the Maths Hubs, have a slightly different idea about what constitutes mastery. They say that it's made up from 5 big ideas. Representation and structure, that's using different representations of the same idea and concentrating on the mathematical structure of problems and concepts rather than simply the procedures. Coherence, advancing understanding through small conceptual steps. Variation, procedural variation of one aspect of a problem to reveal the structure, and conceptual variation, varying the representation. Mathematical thinking, children developing their thinking about different approaches and solutions through dialogue, and fluency, procedural fluency. Some argue that these 5 aspects are aspects of pedagogy and didactics rather than mastery, but all 5 are essential aspects of pedagogy in a mastery approach, And what's absolutely clear is the need for good content pedagogical understanding is fundamental to whatever concept of mastery you have. The NCETM spine materials are probably the best available printed or digital resource to contribute towards building teachers' content pedagogical understanding. A mastery approach is not compatible with laying down set periods within which children have to understand concepts, but we've spoken about the two good reasons why we set notional time limits into a diagram. Two reasons for the blocks taking a very long time in some cases are teachers following the spines like a scheme, following every suggestion in every teaching point, using all of the different types of representations regardless of where their children are in their understanding, and classes having a really poor basic understanding. For instance, if children come from a year group where they've followed, for instance, a scheme that has larger steps of understanding, they may have followed the scheme procedurally, but not brought a good conceptual understanding to the next good year group. In this case, they might need to spend longer on understanding some of the content. A good example is that of number bonds within 10 at the beginning of year 2. If they've not spent the time developing a deep understanding and instant recall of number bonds to 10 in year 1, they do find it difficult to follow. For example, if we know that 3 add 5 equals 8, we know that 23 add 5 equals 28. They just haven't had the preparation. Another, for instance, is the concept of adding mixed numbers in year 5. There are at least 8 clear steps to understand this well, involving varying the sum, going over the boundary, varying whether the denominators are multiples and factors of each other, and whether to use the whole number first method or convert to improper fractions. One commonly used scheme reduces work on this to 2 pages with advice that mixed numbers should be added whole numbers first, but then with questions asking them to convert them to improper fractions, followed by 2 good reasoning contexts. So there's a strong likelihood that children will cover a small amount of ground in mathematical concepts, but not develop any real depth of understanding of them. I think that this is a delivery of a product rather than teaching. Understanding the pedagogy, what the usual misconceptions are, what the small steps are, why, and framing the way that they're introduced to the class based on a good understanding of where all the children are and what their barriers might be, as opposed to simply delivering a product. In that case, some will be able to answer a reasonable amount of questions correctly in a formal test, especially when they've spent an amount of specific preparation time, for instance in year 6. But big disparities will arise within cohorts. Children with low prior attainment or environmental barriers such as poverty to their learning won't make reasonable progress when faced with superficial learning of larger steps. A possible answer to the issue of following the spines like a scheme is S-planning. Learning is a messy process. It's hard to predict, even for an experienced teacher working with children that they know well, how they'll get on with every concept that they'll be introduced to. Unanticipated things come up. Children fly through things you don't expect them to and find others hard going, and then come unstuck over what you thought was a trivial point. And a lesson's probably not the best unit of learning. Learning doesn't take place in lesson-sized blocks. Trying to fit all of the learning into a lesson might mean that some things are more rushed than we'd like, or some things are stretched out more than needed. It can sometimes take longer to design activities that fit into the time than activities that are good for learning. Colin Foster, who works for the EEF and is a general maths guru, suggests planning using a continuous ribbon of ideas that you want your children to learn. He suggests that there are 5 steps to doing this. Many maths hubs highlight the usefulness of using S-planning. They often suggest it because it's a way of planning for the 5 big ideas of mastery where schemes don't contain them. The advantage of using S-planning, particularly with the spine materials, is that the 5 big ideas are already integrated into them, meaning that planning can be streamlined and made to fit each group of learners rather than the time being spent in searching elsewhere for ideas about those 5 pedagogical steps. Thanks for listening. That's an explanation of why I think we should adopt S-planning to work with the spine materials. In the next video, we'll look at some practical ways of how we can do that.